Hello viewers, welcome back to our YouTube channel 3D Parametric Solid Model Drawings. Today we will create an assembly file of Arbor Press in Autodesk Inventor. In this video, you will learn the full modeling process of this model and its components. We have used 10 PAR files and 1 assembly to make this model. If you want to get the file of this model, I have given the link address in the description of my video. By visiting that link, you can get it easily. Okay, that's it. So let's start the tutorial. First of all, we will create an Arbor Press frame like this. Let's start an inch PAR file from here. And click create. Okay, that's it. So let's start the 2D sketch command from here. Okay, and now select the XY plane from the design window to start the new sketch. Okay. Create a line from the part origin. And its length will keep 8.625 inches. Now draw another line from this point. Okay, its length will keep 1.5 inches. Draw 2 more lines on here. Its length 1.5 inches. Okay, that's it. Draw a vertical line from this point like this. Create another line on the upper side and its length will keep 2.5 inches. Apply the dimension between the upper line and the base line. Okay, it will keep 9 inches. Draw one more line on here. Its length will keep 1.184 inches. Now we will draw an arc between the endpoints of the line like this to connect the sketch. Now we will draw a vertical line from the endpoint of the line. Okay. Create another arc over the outside. And its radius will keep 6 inches. Apply the dimension on the inside arc. Its radius will keep 3 inches. Okay. Fix the dimension on this line 3.125 inches. Apply the dimension 1 inches between these two center points of the arc. Fix the vertical constraint between this point and this point. Okay. Apply the tangent constraint over the inner arc and line. Okay, that's it. Now we will fix another tangent constraint over the outer arc and line like this. Okay, alright, now my sketch is fully constrained on the design window, so we will exit from the sketching environment. Now we will activate the extrude command from here. Okay, now see my sketch is automatically selected in the design window. Set the extrude distance value 3.5 inches and click OK. Now see here my first extrude feature is created in the design window. Okay, alright. Now go to the material panel and select the semi-polished material. Okay, that's it. Go to the View tab and select the Two Lights option. Now we will increase the brightness of the model by adding one more light. Okay. See, now my model is looking perfect. Save the PAR file with the name Arbor Press frame in the Arbor Press assembly folder. Click Save. Okay, alright. Now we will create a new sketch over the top face of the frame. Activate the project geometry tool from here and take the project of these three edges of the frame. Draw a horizontal line over the mid of this projected edge. Convert the entire projected lines into construction geometry. Now we will draw an aligned line from here like this and create an arc between this endpoint of the line and center line. Fix the radius of this arc 1.25 inches. Apply the tangent constraint on this line and arc. Okay. Fix the angular dimension 15 degrees between these two lines. Create one more line over the opposite side. Draw another arc on here. Its radius will keep 1.312 inches. And fix the tangent constraint over the both ends of the arc. Now we will create a mirror of these sketch lines and arcs over the opposite side. We will draw one more vertical line on here to connect the sketch. Okay, finish the sketch. Now we will activate the extrude command. I will choose the intersect option. Okay, and then next select the all option. Click OK to finish the command. Now you can see my shape is created as I want. Wow, it looks great. Save the PAR file. Let's start the new sketch over the front face of the model. Now we will take the project of the outer edge of the frame. Okay. Draw a vertical line from here. Now draw two more lines on this bottom side like this. Apply the collinear constraint over the edge and line. Give the dimension 0.375 inches between these two lines. This line dimension will keep 2.365 inches. Now we will give another dimension of 2.434 inches between these two lines. Okay, that's it. Now create an arc on the end points of the lines to connect it. Fix the radius of this arc, it will keep 3.375 inches. Okay, alright. Apply the tangent constraint between this arc and line. Okay. Now we will convert this curve into construction geometry and draw an arc on over it. Okay, finish the sketch. Activate the extrude command and select the sketch profile. Now choose the cut option and fix the distance value of 1.469 inches. Click OK. Now see the result, my slot is cut over the frame. Now we will start the new sketch over this slot face. Okay. Now take the project of these model edges. Okay, alright. Create a vertical line on here and its length will keep 1.984 inches. And take the offset of this outer curve and line inside. The offset distance value will keep 0.375 inches. Okay, that's it. Create one more horizontal line over the end of the sketch. Okay. Activate the slice graphics command from here. Now we will trim this line on here. Okay. Okay, finish the sketch. Now we will activate the extrude command, okay, and select the sketch. Now we will choose the cut option. Fix the distance value 0.125 inches and click OK. Alright, let's start the sketch over this face. Now we will create a circle on here and its diameter will keep 1.75 inches. Take the project of this side edge, okay, and fix the horizontal constraint between the midpoint of the projected edge and center point of the circle. Create another line over the top edge. Okay, fix the vertical constraint on this line and circle. Now we will draw some more lines on here, something like this. Apply the dimension 0.375 inches between these two lines. Create one more line on here and fix the dimension 0.125 inches between this line and center point of the circle. Now we will extend these two lines on this circle. Okay, and trim the circle like this. Create an arc on here. And fix the tangent constraint over this arc. Now my sketch is complete, so we will finish the sketch. Activate the extrude command. Okay, choose the cut option, fix the distance value 0.875 inches and click OK. Alright, now see. Now we will activate the plane command from here. Select the front face and back face of the frame. See, my plane has been created here over the mid of the model. Now we will activate the mirror tool from here and select the two extruded cut features from the browser bar. Now choose mirror plane option and select this plane. Click OK to finish the command. Okay, now see the result. Create a new sketch over this face and take the project of this face. Create a rectangle on here. Apply the dimension 1.75 inches between these two lines. Create another dimension on here. It will keep 0.375 inches. Okay, finish the sketch. Activate the extrude command and select the sketch. Choose the cut option and select two next option. Click OK. See. Now we will create one more extrude cut feature over this face of the model in the following way. Okay, that's it. Now see, my surface of the frame is cleared on here. Okay, it is looking very nice. Now we will change the name of this plane, name it as mid plane, and start the sketch on this plane. Now we will activate the slice graphics command. Okay, create a circle on here and its radius will keep 0.75 inches. Apply the dimension 1.184 inches between side edge and circle. create two horizontal lines like this. And fix the tangent constraint between these two lines and circle. Okay. Now we will trim the extra lines and arcs on here like this. And give the dimension 0.5 inches between these two outer lines. Now draw one more vertical line on here to close the sketch profile. And deactivate the slice graphics command. Now rotate the model in isometric view by selecting the view cube. Okay. Okay, activate the extrude command. And now we will cut this sketch region 1 inches both sides from the midplane by using the symmetric option. Okay, that's it. Now see my slot is cut on here. Save the part file. Let us start the sketch over this face. And take the project of this edge. Now create a circle from this center point. Apply the diameter 1.172 inches. Okay, alright. Activate the extrude command and cut this circle up to the inner slot face. Okay, now see here. In the same manner, we will create one more hole over the opposite side of the slot face. The hole diameter will keep 0.751 inches. Create a new sketch on this face. Okay, and draw the lines something like this. Okay, alright. This line dimension will keep 1.25 inches. Now create an arc on here. Okay, and fix the tangent constraint over the both endpoints of the arc. Okay, finish the sketch. Now we will activate the extrude command and select the sketch. Okay, now choose the cut option and enter the cut depth value 0.594 inches and click OK. Now we will create the mirror of this extrude cut feature over the opposite side of the frame. Activate the fillet command and fix the fillet radius 0.6 to 5 inches. Now we will give the fillet on these two edges of the frame. Okay, alright. In the same manner, we will apply the fillets over some more edges of the frame like this. Now we will create a new sketch on this inner face. And take the project of the mid plane. Draw a rectangle on here. Fix the coincident constraint between the midpoint of the rectangle line and center line. Now we will fix the diameter of this circle 1.063 inches. Okay. Set the dimension 0.75 inches between the center of the circle and outer edge. Now we will fix the tangent constraint on the circle and rectangle lines like this. We will trim the extra line and arc like this. Okay. Convert the center line into construction geometry. Activate the extrude command and cut the sketch through all over the body. Okay, now see. Create a sketch on this face. Now we draw a horizontal and vertical line on the side edge. Okay, and draw an arc on here. Its radius will keep 1.75 inches. Okay, finish the sketch. Cut this sketch region 0.125 inches and click OK. Now we create a mirror of this cut extrude feature like this. And apply the fillets on these four internal edges of the frame. Okay, alright. We will rotate the model in the back position. Let's start the sketch on the bottom face and take the project of this face. Now we will take an offset inside of this outer projected edge. The offset distance value will keep 0.312 inches. Okay, that's it. Finish the sketch. Now activate the extrude command and cut the sketch profile 1.1875 inches. Click OK. Now see the result. Start the sketch over the front face and draw a rectangle on here. Fix the width and height of the rectangle will keep 2.562 and 0.125 inches. Apply the dimension 3 inches between side edge and rectangle line. Fix the collinear constraint on this line and this edge. Now activate the extrude command, choose cut and through all option and click OK. Now see here my another slot is cut over the frame part. Create another new sketch on the bottom face. Now draw a rectangle on here. Fix the dimension 1.999 inches between this line and center point of the arc. Fix the height of the rectangle 3 inches. Apply the collinear constraint between both sides of the rectangle line. Okay, finish the sketch. Now we will activate the extrude command. Okay, rotate the model in this position and fix the extrude distance value 0.5 inches. Now see, my feature is looking perfect. Create the sketch on the midplane. Enable the slice graphics command. Now we will take the project of these two edges and draw an aligned line like this. Set the angular dimension 30 degrees between these two lines. Okay, finish the sketch. Now we will activate the extrude command and select the sketch. Select the cut option and then next we will select the between option. Okay, at first we will select this internal face of the model. Rotate the model and select the opposite side face and click OK. Now see here my taper face has been made. Rotate the model in the rear side and activate the fillet tool. Set fillet radius 0.125 inches. Okay, now we will select these four bottom edge of the part and click OK. Now see, it looks great. Create the sketch over the front face. Okay, alright. Now take the project of this face. Draw a vertical and horizontal line on the mid of the projected sketch like this. Convert the entire sketches into construction geometry. Now we will create 2 points on the both sides of the center line and fix the symmetric constraint on over it. Fix the dimension 1.25 inches between both the points. Apply another dimension 0.25 inches on this point and edge. Now we will create a mirror of these sketch points. Okay, that's it. Finish the sketch. Now we will activate the whole command from here. You can see here my sketch points are automatically selected in the design window. Select the tabbed hole option in the hole dialog box. Choose the distance option under the termination area. Thread specifications are the same which you are seeing here. Okay, hole depth will keep 0.752 inches. And thread depth will keep 0.5 inches. Click OK to finish the hole command. Now you can see here my 4 holes are created on the frame. Okay, it is looking perfect. Now we will create the sketch on this face and take the project of the hole edge. Draw a circle from the hole center point. Its diameter will keep 1.374 inches. Okay, finish the sketch. We will activate the extrude command and select the sketch region. Okay, fix the distance value 0.375 inches and click OK. Create a new sketch on the top face. Draw a circle of 0.125 inch diameter on here. Okay, and take the project of this edge and apply vertical constraint between this edge and center point of the circle. Give the dimension 0.188 inches between this edge and center point of the circle. Okay, alright, finish the sketch. Now we will activate the extrude command and cut this circle 1.355 inches. Okay, that's it. Now we will start the sketch on this face. Draw a circle on here and its diameter will keep 0.406 inches. Apply another dimension 5.625 inches between these two center points of the circle. This dimension will keep 0.75 inches. Okay, finish the sketch. Now we will create a hole over this face by selecting this circle. Now we will create a mirror of this hole over the opposite side of the frame like this. Now we will create another small hole over the front side of the frame like this. Okay, alright. Let's start the sketch on the front face. Draw a vertical line over the mid of these two edges. Now create a rectangle over this edge. Fix the coincident constraint on this rectangle to fix it. Its width will keep 0.749 inches. Apply the collinear constraint between this line and bottom edge. Now we will create a slot by selecting this rectangle by using extrude command. Slot depth value will keep 0.752 inches. Now we will create a mirror of this slot feature over the bottom side of the frame like this. Rotate the model over the back side, okay, and start the sketch on this face. Take the project of these two vertical edges like this. Okay, activate the extrude command, select the sketch and set the distance value 0.67 inches and click OK. Now see my face is plain on here. In the same manner, we will fill this oval surface in the following way. Okay, that's it. Now my frame is looking perfect. Now we will apply the fillet. Now we will apply the fillet to some more remaining edges of the frame. Now we will create one more small hole over the top face of the model like this. Okay, that's it. Create a sketch on the front face. Draw a rectangle on here. And fix the collinear constraint between these two lines. Okay, finish the sketch. Now we will cut this sketch region 1.059 inches. Now we will apply the fillet on these edges of the frame. Okay, the fillet radius will keep 0.125 inches. and apply some more fillets over the inner edges of the slot face. Okay, that's it. Save the par file. Finally, my Arbor Press frame component has been completed here. I hope you may like this model. So now we will close this par file. Okay, and start the new inch par file from here. Now we will start the new sketch over the XY plane. Choose front view. Create a center point rectangle from the part origin, and its width will keep 1.75 inches and height will keep 2.5 inches. Okay, finish the sketch. Rotate the model in isometric view. Now select this line and activate the extrude command. Okay, set the extrude distance value 0.5 inches and click OK. Now you can see here my first extrude feature has been created in the design window. Now we will change the material of the model as semi-polished. Okay, and we will change the light of the model as 2 lights. Okay, save the par file with the name faceplate. Click save. Okay, that's it. Let's start the new sketch over the front face. Now we will activate the project geometry command from here and take the project of XZ plane and YZ plane. Okay, now see. Activate the point tool from here. Okay, and create a point on here and select this point and this side edge and apply the dimension 0.25 inches. Now we will select the upper edge of the model and this point. It will also keep 0.25 inches. Now my point is fully constrained on here. Okay. Now we will activate the mirror tool from here. Okay, and select this point. Click continue button. Select this vertical line. Click apply. Okay, now we will select these 2 points. Okay, select this line. Click apply button. Now you can see here my 4 points has been created on here. Now we will convert the entire sketches into construction geometry. Okay, finish the sketch. Now we will activate the whole command from here. Okay. Now you can see here my 4 sketch points are automatically selected on here. The whole preview is visible in the design window. Okay. Choose flat option under the drill point area. Under the termination area, choose the through all option and click OK. Now see my 4 holes created over this part. Now we will activate the fillet tool and apply the fillet over the 4 corner edges of this extrude feature. The fillet radius will keep 0.25 inches. Click OK. Now see my part is looking perfect. Now we'll start the sketch over this face and create a center point rectangle from the part origin. Its width will keep 0.875 inches and height will keep 1.5 inches. Okay, finish the sketch. Choose isometric view by selecting the view cube. Now we will cut this rectangle 0.125 inches from here. Okay, now see, my slot is cut on here. Create another new sketch over this internal slot face. Now we will create a point over the center line and fix the vertical constraint over this point and the center point, and apply the vertical dimension between these 2 points. It will keep 0.5 inches. Okay, now we'll take the project of XY plane. Okay, activate the mirror tool, select this point, click continue button, select this line, click apply. Now see, finish the sketch. Now we will activate the hole command and select the tabbed hole option from here. Okay, choose the distance option under the termination area. Now we will select the 0.19/10 option under the size area. Under the designation area, we will select the 10-32 UNF option. Okay. Hole depth value will keep 0.75 inches and thread depth will keep 0.5 inches. And click OK. Now see, my 2 tabbed holes are created on this face. Okay, it looks great. Now we'll create a new sketch on this face. Okay, and create a circle from here. Its diameter will keep 0.73 inches. Now we'll apply the vertical constraint between the center point of the circle and part origin. Okay, apply the dimension between these 2 points. It will keep 1.472 inches. Okay, finish the sketch. Now we will cut this circle through all over the body. Like okay, now see, my another slot is cut on here. Activate the fillet tool and set the fillet radius 0.125 inches. Okay, now we will select these 4 internal edges of the slot face like this. And click OK. Now see here, my fillet has been applied over these 4 edges. Okay, it looks great. Now my part has been completed on here, so we will close the part file. Now we will create a new part file, name it as pinion shaft. Okay, so we will create a new inch part file on here. Let's start the new sketch on the XY plane. Now we will take the project of x-axis, okay, and convert this line into construction geometry. Now we create a slanted line on here like this and apply the align dimension on this line. It will keep 0.586 inches. Now we will apply the angular dimension 7.5 degrees between this line and center construction line. Okay, now my line is fully constrained on here. Now we'll create another line over the opposite side like this. And its align dimension will keep 4.404 inches. Now select this line and center line and apply the same angular dimension 7.5 degrees that we had done earlier. Now we will create an arc from this endpoint of the aligned line like this and set the angle of this arc. It will keep 3.86 degrees. Its radius will keep 0.404 inches. Okay, now see. Now we will create another arc from this arc endpoint. Okay. And apply the tangent constraint between these two arcs like this. Now we will fix this arc angular dimension. It will keep 86.695 degrees. Its radius will keep 0.02 inches. Okay, now see. Now drag the sketch like this. Create a line from the arc endpoint. Its length will keep 0.047 inches. Like okay. Apply the tangent constraint between this line and this arc. Now we will create an arc between this line endpoint and center line. Okay. And apply the angular dimension of this arc. It will keep 16.396 inches. Fix the radius of this arc. It will keep 0.109 inches. Okay, that's it. Now we will activate the document settings option from here. Okay, go to the units tab and change the angular dimension decimal value up to 3 places. Click OK. Now see the result. Now we'll create another arc from this point. Okay, like this. And fix the angular dimension of this arc. It will keep 21.363 degrees. Now we will fix the radius of this arc, 0.268 inches. Now select the end point of this arc and center point and fix the dimension 0.583 inches. Okay, now my sketch is fully constrained on here. Select this line, okay, and convert it to construction geometry. Now we will activate the mirror tool from here, okay, and first of all, we will select the entire sketches like this. Select this one, and this one. Okay, choose mirror line option and okay, select this construction line. Click apply button to create the mirror of the sketch. Now you can see here my sketch is mirrored on here over the opposite side of the center construction line. Now we will create one more arc between these two endpoints of the sketch to connect it. Okay, its radius will keep 0.586 inches. Okay, alright, finish the sketch. Choose the isometric view. Now we will activate the extrude command. Okay, it will automatically select the sketch profile. Okay, now see here my preview is visible here in the design window. Now we will choose the reverse direction button on here and fix the extrude distance value 1 inches and click OK. Now we will change the material of this model as aluminum polished. Okay, now see, my feature is looking perfect. It looks great. Save the bar file with the name pinion shaft. Click save. Okay, alright. Okay, so now we will activate the circular pattern tool from here. In the features tab, we will select this extrude feature from the browser bar. Okay. Now select the rotation axis option. Okay. We will select this edge. Okay, alright. Now see, my circular pattern preview is visible here in the design window. Fix the pattern count value 12 and click OK. Now see here, my teeth of the pinion are created here. Okay, it is looking very fine. Let's start the sketch over the rear side of the model and draw a circle from the center point. Its diameter will keep 1.172 inches. Activate the extrude command. OK. Extrude the circle 2.813 inches from this face. Okay, that's it. Now we will create a new sketch over the front face. Draw a circle from the center point. Its diameter will keep 0.748 inches. Now we will extrude this circle 1.187 inches from the front face. Activate the chamfer tool from here. Fix the chamfer distance value 0.0625 inches. OK. And apply the chamfer on all the teeth of the pinion and model edges like this. Okay, now see. It looks great. Now we will start the new sketch over the exact plane. I will choose the slice graphics option. Draw a circle on here and its diameter will keep 0.515 inches. Now take the project of the top edge and fix the dimension 0.5 inches between this edge and center point of the circle. OK. Fix the vertical constraint between these 2 points. OK, finish the sketch. Now we will create a through-all hole over the cylindrical surface of the model by selecting this circle. OK, alright. Now we will create a sketch over the teeth face. Choose the front view. And take the project of the edge of one tooth and outer circular edge like this. Activate the section view. Convert the outer edge into construction geometry. Now we will draw two arcs at the end of the projected sketch. Fix the tangent constraint over these arcs like this. Now we will create an offset of the outer circular edge. Okay. And trim the extra lines and arcs on here like this. Now we will draw an aligned construction line between the endpoints of the arc. Okay, alright, create another aligned line over the outside and apply the parallel constraint between these two aligned lines. Fix the dimension 1.575 inches between outer circular line and center part origin. Okay, finish the sketch. Now rotate the model in this position and activate the Revolve command from here. See here, my sketch is automatically selected in the design window. Select the aligned construction line for the axis of revolution. Now you can see the Revolve feature preview is visible here in the design window. Choose the cut option and click OK to finish the command. Now see, my slot is cut over the cylindrical surface of the pinion shaft by using this tool. It is looking very fine. Now we will activate the circular pattern tool from here, okay, and select the revolution 1 feature from the browse bar. Choose the rotation axis option, okay, and then next we will select the outer cylindrical surface of the pinion. Fix the occurrence count value 12 and click OK to finish the command. Now my model is looking perfect. Save the part file. Rotate the model on the rear side. Okay, now we will activate the hole command. Choose the concentric option. At first we will select this face. And then next select the outer circular edge. Okay, now we will choose the tabbed hole option. All the settings are the same on here. I will choose the full length option under the thread area. Hole depth value will keep 8 mm. And click OK. Now we will change the material of the model as chrome polished on here. It is looking very nice. Okay, now see, my part is complete on here, so we will close the part file. Now we will create another new inch part file on here. Okay, and now select the XY plane to start the new sketch. Okay, draw a center point rectangle from the part origin. Its width and height will keep 0.75 inches. Okay, finish the sketch. Extrude this square 7.75 inches on the front side. Okay, alright. And change the material of this model as chrome polished. It looks great. Save the part with the name RAM. Okay, that's it. Let's start the new sketch over the front face. Now choose the front view. Create a sketch profile something like this. And apply the vertical constraint between the midpoints of the upper and lower lines. Okay, now we will add the dimension on here. It will keep 0.937 inches. The top line dimension will keep 0.192 inches. And the bottom line dimension will keep 0.061 inches. Apply the angular dimension 40 degrees between these two slanted lines. Okay, finish the sketch. Now we will cut this sketch region through all over the body by using extrude command. Now see my slot is cut on here. Activate the rectangular pattern tool from here. First of all, we will select the extrude cut feature. Okay, click continue button. Okay, now we will select this edge for the pattern direction. Choose the flip side button. Okay, and set the column count value 23. The spacing value will keep 0.262 inches. And click OK to finish the command. Now see here, my teeth are created over the RAM model. It looks great. Now my part is completed on here, so we will close the part file. Okay, that's it. Now we will create another new inch part file on here. Okay, now select the XY plane to start the new sketch. Okay, alright. Create a circle over the center point. Fix the diameter 0.5 inches. Okay, finish the sketch. Now we will extrude this circle 10 inches on both sides from the XY plane. Change the material of the model as flaked satin blue. Okay, it looks great. And save the file with the name lever arm. Okay, click save and close the file. Now create a new part file from here. Okay, choose XY plane to start the sketch. Now we will create two circles on the center origin point. An outer circle diameter will keep 0.75 inches and the inner circle diameter will keep 0.5 inches. Okay, finish the sketch. Extrude this sketch region 0.625 inches in this direction. Now change the material of the model as smooth medium gray. Okay, alright. Now we will apply the chamfer on the front edge. Fix the chamfer distance value 0.031 inches. Click OK. Now we will apply the fillet on the back edge. Okay, that's it. Save the file with the name handle cap. And close it. Create another new inch part file from here. Okay. Start the sketch over the XY plane. Now we will create two circles on here from the center origin point. and outer circle diameter will keep 1.125 inches and the inner circle diameter will keep 0.75 inches. Okay, finish the sketch. Now extrude the sketch 0.375 inches on here. Save the par file with the name collar. Apply the chamfer on the front circular edge. Now we will create the sketch on the XZ plane. Take the project of the entire model like this and convert all the sketches into construction geometry. Draw a point over the center line, okay. Fix the vertical and horizontal constraint over this point like this. Okay, finish the sketch. Now activate the hole tool. Choose the reverse direction button. Select the through all and tap the hole option on here. We will select the 0.1-10 in the size area and select the 10-32 UNF size under the designation area and click OK. Now see, close the par file, okay. And let's start the new inch par file. Create a sketch on the XY plane. Now we will draw a circle from the center point. Its diameter will keep 3.5 inches. And extrude it to 0.5 inches. Okay. Now draw one more sketch on this face. Take the project of the model edge and YZ plane. Create a circle on here. Its diameter will keep 2.25 inches. And convert the entire sketches into construction geometry. Now we will draw a circle over the intersection point of the center construction line and the previous circle. And its diameter will keep 0.56 inches. Now draw two vertical lines on the both sides of the circle. And apply equal constraint over these two lines. And tangent these two lines on this center circle. Now we will erase the extended line and arc by using the trim command. And draw a center point arc on here to close the sketch profile. Okay, finish the sketch. Activate the extrude command and cut this sketch profile through all over the body. Now we will pattern this extrude cut feature 4 times by using a circular pattern tool. Save the file with the name table plate. Now we will change the material of the part as chrome polished. Okay, it looks great. Now we will apply the fillets on these 4 slot edges of the part like this. It is looking very nice. Now we will create a small hole over the center of this plate. Okay, now my part is completed on here, so we'll close the part file. Next, we will create 2 miscellaneous part files, which name is groove pin and GIB plate in the following way. Okay, close the par file. Okay, that's it. Finally, all the par files of the Arbor Press model are finished here. So now we will create a new inch assembly file in Autodesk Inventor. Click create. Okay, that's it. Now my assembly design window is visible on your screen. First of all, we will activate the place component command from the component panel. Okay, now we will select the arbor frame part that we had created first. Okay, alright. And place the frame in this assembly by choosing the place grounded at origin option. This time my assembly is fully constrained. Here no needed to give any mates over this part because this part is grounded. Okay, alright. Save the assembly with the name Arbor Press. Click save. Now we will activate the place component command from the design window and insert the part faceplate on here. Okay. Now we will rotate the assembly in this position. Okay. Activate the free rotate command from here. Rotate the faceplate model in this position. Now we will activate the constraint command from the relationships panel. In the place constraint dialog box, the mate constraint will automatically be selected by default. Okay, now we will select the whole axis of the faceplate and the whole of the frame. Okay, and apply the axis mate between them. Okay, alright, now see here. and fix another axis mate over the opposite side holes. Okay, now select this one and apply the mate constraint between them. Okay, now my part is fully constrained on here. We will insert the pinion shaft in this assembly. Rotate the pinion 90 degrees 2 times along the y-axis in the following way. And fix the shaft over the large hole of the frame like this. Now we will fix the mate constraint between the inner face of the frame and the inner teeth face of the pinion. Okay, now see the result. My pinion is rotating on the whole axis of the frame. Now we will insert the lever arm on here and apply the axis mate between the cylindrical surface of the arm and the whole of the pinion. Now we will apply another mate constraint between the XY plane of the lever arm and XZ plane of the pinion. Okay, now see the result. Now we will insert the thumb screw into the assembly. Rotate the model in the following way. And fix the screw over the front hole of the pinion. Okay, that's it. Now we will give the mate constraint between these two faces of the parts. And fix the distance value 0.125 inches. Now we will apply another mate constraint between the XZ plane of the thumb screw and YZ plane of the pinion shaft. Now we will insert the handle cap into the assembly. And fix the cap over the both sides of the lever arm in the following way. Okay, alright, my handle is ready to move on. And now we will place the table plate part in this assembly. And fix the access made between the small hole of the plate and frame. Now we will apply one more mate constraint between these two faces of the parts to fix it. Now we will change the color of the plate as gray. Okay, return to the assembly. Now we will fix the angle mate constraint between the exact plane of the table plate and this inner face of the frame. Fix the angle minus 24 degrees and click OK. Save the assembly. Now place the collar part on here and rotate the part on the back side. Apply the mate constraint between the hole of the collar and the outer circular face of the frame. Now we will fix one more mate constraint between this face and back face of the collar part. Okay, alright. Now place the GIB plate in this assembly and fix the mate constraint between the face of GIB plate and inner slot face of the face plate. Now we will hide the visibility of face plate. Okay, we will activate the constraint command and apply the flush mate between the top faces of these two parts and set the offset distance value 0.605 inches. Now rotate the assembly and fix another flush mate between the front face of the GIB plate and frame. Fix the offset distance value 0.559 inches. Now we will insert the part group in and fix the pin over the whole of the table plate. Now we will insert the RAM model in this assembly. Okay. Now rotate the RAM part in this position. Now we will fix the mate constraint between the front face of the RAM part and the inner face of the faceplate. Fix another mate constraint between the side face of the RAM and the inner side face of frame part. Now we will drag the RAM model on here to check the result. We will insert some more bolts over the holes of this assembly by using the Content Center par files. So now we will activate the Place from Content Center command from here. Go to the bolts folder and choose the ANSI option in the size filter section. Now go to the socket head bolts folder and choose the hexagon socket head cap screw on here. We will expand the table from here. Okay. Now we have selected 1x4-20 UNC 7x8 size bolt on here and click OK to place the bolt in this assembly. We will insert the 4 copies of this bolt on here. You will see also be seen on the browser bar. Okay. Now we will place the bolts by using the insert mate command in the following way. Okay, now my 4 bolts are fixed on the faceplate. Activate the Place from Content Center command once again. On here, we will go on the Set Screw folder. Now we will select the BS4168 cap screw on here. We will expand the table from here. Now we have selected a 5 mm size cap screw on here and place the 2 copies of the cap screw in this assembly. Okay, now we will rotate the set screws in this position. Now we will activate the constraint command from here. Okay, now we will apply the axis mate between this set screw and this hole of the plate. Okay, alright. In the same manner, we will apply another axis mate over the second bolt and second hole of the faceplate. Okay, alright. Now we will apply a flush mate over this face of the screw and faceplate. Alright, and fix the offset distance value 0.15 inches. Now my cap screws are successfully fixed over the assembly. Okay, that's it. Now we will rotate the assembly on the opposite side. Now we will place the set screw over the whole of the collar part. Okay. We have selected a 5 mm nominal size set screw on here. Okay. Now we will rotate the screw in this position and fix over the whole of the collar part. Okay, alright. Now we will drag the pinion and ram component on here. See here, there is no relationship established between these two components. Both the components are rotating separately on here. Next, we will link these two components to each other by using the rotational oblique translation mate command. Okay, that's it. Rotate the model on the opposite side. Activate the constraint tool. Okay. Now we will go on the motion tab in the place constraint dialog box. On here we will choose the rotational oblique translation mate command. Under the solution area we will select the reverse option. Okay. Now choose first selection. We will select this face of the pinion model. Okay. Next, we will choose the second selection. Select the vertical edge of the ram part. Okay. Fix the travel distance value 3.142 inches. And click OK to finish the mate command. You can see this mate to go on the browser bar. Okay. Now we will drag the lever arm to check the result. Now my lever arm and ram part files are simultaneously rotating on here by using this mate. Okay, it looks great. Now we will show the animation of this model by using the drive constraint command. Okay, alright. Let's go to the relationships folder and we will change this angle mate value minus 0.2420 degree on here. Okay, that's it. Here we will give a new angle mate between the exit plane of the pinion shaft and this inner face of the frame. Okay. Okay, now select the angle mate, right click and choose the drive option. Fix the end angle value 180 degrees. Okay. Now I will choose the clear screen option to view the full assembly. Okay. Click the forward button to animate the constraint. Okay. Now see the result. It looks great. Now I will click the reverse button to the back position. Finally, my Arbor Press assembly has been completed here in Autodesk Inventor. I hope you will enjoy this video. If you may like this video, please like and subscribe to our YouTube channel. Please share this video with your friends and colleagues. Okay friends, goodbye.